Good day, everyone. Today, we're diving into an exciting mathematical journey into tangent, normal, and binormal vectors, fundamental concepts in calculus and motion analysis. This presentation is part of JIM319 and is specially prepared for Professor Madhya Dr. Muhammad Ashraf bin Mansur at University Sains, Malaysia. My name is Sathya Seelan, and I am a mathematics department student at University Sains, Malaysia. My matric number is JP11322222, and I am currently taking the course JIM319, Vector Calculus for the 2024/2025 academic session. Let's dive into the topic. Objective of presentation. Firstly, we want to understand what is a vector-valued function or a vector function. Secondly, we want to explain the concept of tangent, normal, and binormal vectors. Thirdly, we want to derive the mathematical formulations of tangent, normal, and binormal vectors. Next, we are going to look on a worked example of the concepts of tangent, normal, and binormal vectors. Finally, we are also going to see the applications in real-world scenarios. Have you ever wondered how a roller coaster smoothly follows its track, speeding up on slopes, slowing down on curves, and twisting through loops? The path of a roller coaster can be described using a vector-valued function in 3D space. Every point on the track has a direction, tangent vector, a curvature, normal vector, and a twisting force, binormal vector. Engineers use these vectors to ensure safety, speed control, and smooth motion of the ride. Just like a roller coaster needs precise calculations for a thrilling yet safe ride, vector-valued functions help us analyze motion in physics, robotics, and engineering. Let's explore how these vectors work. What is a vector-valued function or vector function? Vector-valued functions provide a useful method for studying various curves, both in the plane and in three-dimensional space. We can apply this concept to calculate the velocity, acceleration, arc length, and curvature of an object's trajectory. What is a formal definition of vector-valued function? A vector-valued function is a function where the domain is a subset of the real numbers and the range is a vector. In 2 dimensions, r of t equals x of t times I vector plus y of t times j vector. In 3 dimensions, r of t equals x of t times I vector plus y of t times j vector plus c of t times k vector. What is a parameter t? The parameter t can lie between 2 real numbers. A is less than or equal to t, which is less than or equal to b. Another possibility is that the value of t might take on all real numbers. We often use t as a parameter because t can represent time. Now, let's get the basic idea on the concepts tangent, normal, and binormal. Shall we? Concept of tangent. What is a tangent? Definition: the unit tangent vector to a curve at a given point. How to understand a tangent. Consider a car driving along a curvy road. The tighter the curve, the more difficult the driving is. In math, we have a number, the curvature, that describes the tightness. If the curvature is 0, then the curve looks like a straight line near this point. If the curvature is a large number, then the curve has a sharp bend. Formula of tangent vector is t of t equals the derivative of r of t divided by the magnitude of the derivative of r of t, where r, t, represents the vector-valued function of motion. Interpretation: it represents the direction of the curve. Also very essential for determining velocity in physics. Now let's tune in to the concept of normal. What is a normal? Definition: the unit vector perpendicular to the tangent vector, pointing towards the curve's concavity. How to understand a normal. Think of a normal vector as the direction of bending of a curve or surface. Simple analogy: imagine you're driving on a winding road. The tangent vector points in the direction you're moving. But where is the curve bending? That's where the normal vector comes in. It points toward the inside of the turn, showing the direction of curvature. Now, observe the illustration provided. T, tangent vector, points in the direction of motion, and normal vector points in the direction the object is turning. Let's look on the normal vector formula. N of t equals the derivative of t divided by the magnitude of the derivative of t. Interpretation. It shows how the curve bends. It is important for acceleration in curvilinear motion. Finally, we have come to the concept of binormal. What is a binormal? Definition: the unit vector perpendicular to both the tangent and normal vectors. How to understand a binormal? Think of the binormal vector as the vector that completes the 3D coordinate system for a moving curve. It shows the twisting motion of the path. Simple analogy. Imagine you're holding a phone and tilting it while following a curved path. The tangent vector shows where you're moving. The normal vector shows where the path bends. The binormal vector tells you how the whole system is rotating in space. Now observe the curve illustration given. It shows the relationship between tangent vector, normal vector, and binormal vector. T, tangent vector, points along the curve's direction. N, normal vector, shows the direction of bending. B, binormal vector, perpendicular to both, indicating the twist in motion. The formula of binormal is simply B of t equals T of t cross N of t, where t represents the tangent vector and N represents the normal vector. Interpretation. It tells us how the curve twists. Now let us see a worked example on the vectors concept.
Oh, she's sweet but a psycho, a little bit psycho. At night she's screaming, my mind. Oh, she's hot but a psycho, full of precious right though. At night she's screaming, my mind. Grab a cop gun, kinda crazy. She's poison but tasty. And people say run, don't walk away. And she's sweet but a psycho, a little bit psycho. At night she's screaming, my mind. Make you curse, I see your blessing. She'll rip your shirt within a second. You'll be coming back for seconds. With your play, you just can't help it. No, you'll play along, let her lead you on. They see and people say run, don't walk away. And she's sweet but a psycho, a little bit psycho. At night she's screaming, run, make you curse, I see your blessing. She'll rip your shirt within a second. You'll be coming back for seconds.
We have done understanding the concept of vector and went through with a worked example. Now, it's time to understand the application of T, N, and B vectors in real-life scenarios. Here are a few fields that rely on the concepts of tangent, normal, and binormal vectors. Can you guess which ones? Let's find out. The astronomy field. Using Newton's laws of motion, astronomer Edmund Halley predicted that a comet seen in 1531, 1607, and 1682 was actually the same comet following a curved orbit, returning every 76 years. Though he never lived to see it, his prediction was confirmed in 1758, and the comet was later named in his honor, Halley's Comet. Mathematical insight. Halley's Comet follows a 3D orbital path, which can be analyzed using tangent vector, shows the direction the comet moves at any point. Normal vector points toward the curvature of its path, influenced by gravity. Binormal vector helps define the rotation of the orbit in space. Now let's look into robotic field. Robotic arms in manufacturing and surgery follow precise 3D paths controlled by vector-valued functions. The tangent vector ensures the arm moves smoothly in the right direction. The normal vector helps adjust for curves and rotations. The binormal vector aids in maintaining the correct orientation for gripping or assembling objects. In 3D animation and gaming, cameras follow a smooth curve defined by vector-valued functions to create cinematic shots. The tangent vector controls the camera's movement direction. The normal vector helps maintain a stable view by adjusting the tilt. The binormal vector stabilizes roll effects, preventing unwanted rotations. Finally, genetic engineering field. The DNA double helix is a perfect example of a parametric curve defined by a vector-valued function. The tangent vector shows the direction of the helix at any point. The normal vector determines how tightly the helix coils. The binormal vector helps in understanding molecular interactions. In muscle movements, vector functions help model joint rotations and human motion analysis for prosthetics. That brings us to the end of my presentation. I truly appreciate your time and attention. I hope you found this insightful and valuable. Thank you for listening, and if you have any questions, I'd be happy to answer them.